In today's webinar, I'll give you a short introduction of what MapleMBSE is and how it will be useful in your MBSE process. And then we will discuss how the quality check or checking if your model is consistent in the MBSE process works. So this is more of defining the scope for how MapleMBSE can fit in the validation process of your MBSE model. And then we will discuss in brief about functionality of MapleMBSE, which is the query path expression, using which we will define some custom rules. So I already have defined certain custom rules and created certain views in MapleMBSE that we will also discuss. And we will see how you can define your own rules and check the model consistency based on your own modeling rules and modeling practice and so on. So I'll just give you a general validation rules or some common validation rules that could be applied to MBSE process, but you will see that how you can customize it based on your own project or your different modeling terminologies and so on. So MapleMBSE is a tool that could bring in different users with different knowledge of MBSE or the modeling knowledge to contribute to develop a system model. The best advantage with MapleMBSE is that it can accelerate the introduction of MBSE in your enterprise. That is, like you will certainly have stakeholders who has to contribute to the model creation. But they might not have the right level of knowledge, or they might not understand how the ARCADIA methodology works and so on. But using MapleMBSE, you can create certain views that is appropriate for the user, or in a way that it's easy for them to interact with the model and so on. And you can customize MapleMBSE to fit to different domains. So MapleMBSE can be used by stakeholders whose daily job is not to work with the modeling tool and so on. It can capture the knowledge in the right way and save this information to a model and so on. And this eventually reduces the project risk because the stakeholders are interacting and contributing in a right way to the model, and you can consistently check on or review the model with them because they see certain information from the model in a way that's understandable to them. So this is basically what MapleMBSE is. So how MapleMBSE achieves this is MapleMBSE uses Excel interface to your system model. So you will be able to generate different custom views, like say for safety analysis, or to import requirements, or to see if requirements can be traced to certain functions and so on. So these kinds of customizable views could be created, and MapleMBSE will maintain synchronization between the Excel view and the system model. So it is not just export or import of model information like how you see in a traditional Excel connection. So MapleMBSE is a kind of a modeling tool which will have the connection between your system model and the Excel interface. So a user interacting with MapleMBSE's Excel interface, their working or their update to the model will be same as how a user is going to use Capella to update a model and so on. And we have connections to different platforms like Rhapsody, Teamwork Cloud, and also to Capella. So I have given you just a very short introduction of what MapleMBSE is. We do have other webinars that go in detail, explains how the connection with Capella works, how you can update a model in Capella and so on. So this is more of like a short introduction for new users, and to give you an idea of how the following session is going to be. Say in our MBSE process, we want to do the verification and validation in our whole development process. But the scope of today's webinar, or where you can fit MapleMBSE in this verification and validation, is in the model development stage. So we are not actually verifying or validating the model as a whole, like to run certain analysis or to run simulation and so on. So that's not where MapleMBSE is being used with. So MapleMBSE is more to check the quality or consistency of the model that is being built. For example, say you want to make sure that all functions are traceable back to certain requirements, or to see if a requirement, if there is a requirement that is not being satisfied or is being traced to a model element and so on. So these are the type of validation that MapleMBSE can help you with. And doing a quality check in MBSE process is very challenging, because the main reason is we want to have a collaboration where you bring in different users with different modeling knowledge and at different levels of your model development process. So you would set certain modeling rules and practices, but to make sure that all the users who are interacting with the model at different levels of the development process, you need to have certain rules and practices, and MapleMBSE can be used as a tool to enforce these rules, to do a validation check at different stages and so on. The other challenging aspect is reviewing the model itself. The bigger the model or the larger the model, it's very hard to review, because there is a lot of information in the model. So you need a flexible query language or a flexible views that could generate a certain aspect of the model and display it to you in a very consistent manner, or in a readable format. And then we also want to check the consistent and the completeness of the model. Like I mentioned in the previous slide, we want to know if there is a requirement that is not linked to any model element, or if there is a function that's not being allocated to a behavioral component and so on. So we want to verify these at different stages of the development process also. And again, we want to create flexible views, because like say a matrix or a table or a certain information of the model, instead of displaying the whole model or exposing a lot of information, we want to focus, say, on a certain aspect of the modeling. Like you want to just see probably like a physical function that has not been allocated to a behavioral component and so on. And the other challenging with checking model quality is also reusability. If you define certain constraints, or if you define certain validation rules, you want to use these validation rules with different projects also, or at different stages of your development process. But this is again challenging in traditional tools, because the whole model is continuously evolving. There is different users interacting with the model and so on. MapleMBSE can help you address all these challenges. And in the following slides, we will see how MapleMBSE can help you with this. Say, as a validation rule, like on the abstract level, for example, say functions that are being defined on the logical architecture level or the system architecture level, we want to know if the functions are traceable. Like, if all the functions in, or at least the top level functions in the logical architecture are realized or traceable back to the system functions. And if you have defined your requirements, is all your requirement linked to certain components, or if there is a certain property or some custom field that you have defined, for example, to say once a requirement is linked to a component or linked to a function, you want the user to change the status of requirement to a certain value. And you can again use MapleMBSE to see how many requirements. For example, let's say the status has to be changed to either reviewed or pending. You can use MapleMBSE to query the whole model and display you the requirements that has status as pending or reviewed, or any custom defined values that you have defined to your Capella model. And also, for example, say as a modeling practice, you always want your functional ports to be allocated to component ports. Again, with MapleMBSE, you can query the different architecture level. For example, say you want to query the functions in the physical architecture, like the physical functions, and see the ports of the physical function should always be allocated to a certain component ports and so on. So this is how the common queries that you can create with MapleMBSE and verify and generate views to review this and so on. So in order to create these custom queries, MapleMBSE is based on a transformation language, which is called query path expression. So a query path expression is very similar to XPath to query model element. So it's basically a query to get information from your model. So a query path expression, so we will see in detail what the query path expression or what the contents are going to be. But in general, these three terms or what will comprise in the query path expression. Classifier. So classifier is a type of element that we want to bring into the MapleMBSE template. Like, for example, if it's a physical component, physical function, or a logical component, and so on. And attributes, they are nothing but just the properties of these classifiers, like name of the physical component, or if you have defined your own values using the PVMT profile in Capella, you want to bring in certain attributes, say the mass of the physical component, or for example, if you have defined power consumption, the power consumption value of the physical component, and so on. So these are attributes. They are nothing but some properties that define the classifier. And finally, the references. So references are nothing but they are pointers. Like, say, you have a relation that, like the functional exchange. So functional exchange connects the function 1 to function 2. So the reference is nothing but the pointer that the functional exchange has that points to one function, and the which is the source, and the other function, which is the target. So that's what we mean by reference. So the query path expression is nothing but it's just the combination of all these three information in a structured format, and based on this, MapleMBSE gets the information and displays it to you in Excel. So based on what we discussed in the previous slide, just with the attributes, the classifiers, and the references, we build a configuration file. A configuration file is where you define all the queries and use the configuration file to get information from your model. So a configuration file basically has 5 modules. The echo import. So the echo import is where you say which type of model that you want to open in MapleMBSE. If you remember from my previous slide, I mentioned that we also have connection to Rhapsody. We have connection to Teamwork Cloud through Cameo, and also to Capella. So echo import is where we actually define if we want to work with a Capella model or a SysML model, and so on. And then with the workbook and the worksheet template, so these two modules is what gives you control over how the information has to be displayed in Excel. So you define a name for the worksheet, you define where your table should start from, if your table should be a vertical table, or if your table should be a matrix, and so on. So this is what is defined in the workbook and the worksheet template. And also the arrangement of the information. For example, if you want to display physical component name in one column, value of the physical component in the next column, the default value for it, and so on. So this is what is defined in the worksheet template and the workbook. The data source and the sync table schema is what the body of MapleMBSE is, or this is what basically uses the query path expression. Data source is nothing but it's a pointer to the part of the model we want to open in MapleMBSE. So for example, let's say if you want to bring in all the physical function from the Capella model into your Excel template. So data source you will define within your model package. There are different architecture. You specifically want to get the physical architecture. So inside physical architecture, you have a root physical function, and inside root physical function is where you define your functions at different levels. So data source is nothing but a pointer. You mentioned that you have to navigate the model in such a pattern, and you want to just get to the physical function. And in the sync table schema, so this is where you define what kind of information of a specific model element you want. Like for the physical function, if you want to get the name of the physical function, if you want to get any other attribute of the physical function, or if you want to get how this physical function is linked or is being realized from a logical function and so on. So the schema or the sync table schema is where you actually define what information of a model element that you want to be displayed in MapleMBSE. So a configuration file is just a combination of all these three. And if you remember from the slides before, you can include certain filters to a classifier. So for example, if you want to get the physical component, you can mention a filter like, so you want to get a physical function that is called physical component that is called as, let's say, the top level component. And you can define a filter because if you do not define a filter, MapleMBSE will list all the physical component that's in the model. And you can put certain filters, like say you have defined physical component in such a way that each physical component is a subsystem, and each of the subsystem is going to have other subcomponents. So with the filter, you can say, for example, let's say in the IFE, in the sample that comes within Capella, the in-flight entertainment sample, you can say, for example, the remote control. So remote control is a physical component, and all other subsystems or sub parts of the remote control is inside the top level component. You can apply a filter saying you do not want to see any other component. You want to only see the remote control and its subcomponents. So this is where you use the filter. So a type of filter that we have defined or added to the query path expression is called a predicate filter. So a predicate filter is nothing but it's just a Boolean that returns either true or false value. For example, you can say you want to display certain requirements that has a certain value. So if the expression is true, only that specific requirements will be displayed. And this is how you will define your own rules, and the predicate filter will help you to validate your model. Again, we will see in detail how we can use predicates to define the certain rules, and how you can filter your whole model to get the information that is of relevant to your verification or your validation rules and so on. So some aspects of the predicate filter are like you can use not. For example, let's say you want to display requirements that are that has no relation to any of the physical components. So for example, like I will just create a query that says I want to display all the requirements, and then if I use which has a certain tag value, and then if I use the not for the predicate, it will just display me all the requirements that do not have the tag value and so on. So you can use the combination of the logical operators like and, or, and not, and you can use them in combination to define your own set of rules. So for example, let's say you want to display the physical component that has no functions allocated to it. So I will define a predicate that says I want to get the physical component without any functional allocation. So that's what the first predicate here means. The second one, I am just getting physical component that has no relation to it, like any kind of relation. So in the first case, we filtered out the physical component that only does not have a functional allocation. In the second case, I'm filtering out physical component that has that do not have any kind of relation to any model element in a Capella model. And let's say the predicate that is called logical function in and logical function out. So this is just a predicate that I want to see how many inputs a function has or how many outputs a function has. So what this predicate specifically will do is it will only display me logical function which has at least 3 or more input ports. The next one will display me logical functions that has at least 3 or more output ports. And the last one you can see here that I can just combine those two information and display a logical function that has at least 3 or more both input and output ports. So this is how you can combine different predicates to display and customize your views. So to check the predicates and the model correctness, to check the predicates and to check the model correctness, you can apply it at different levels of your model development. So it could be at your operational level or at your logical level or your physical architecture level and so on. So all you need to do is you will define your predicates and you will connect the predicates to the, you will connect MapleMBSE to the Capella model, and based on that, you will develop, you will generate your own views based on these queries and so on. So as a workflow demo, what we will see is I have already defined certain predicates. We will just launch MapleMBSE, connect to a Capella model, and we will view that information in Excel tables. So again, like in the meantime, if you have any question, you can post it into the Q&A, and I'll be able to answer to that. Okay. So here I have the in-flight entertainment sample that is already open in Capella. And I have already defined certain predicates in MapleMBSE. So some of the predicates that, in addition to the ones that I've already defined, we will also create some queries to display requirements that has a status as reviewed, which has a status as pending, and we will also display requirements that does not have a satisfied relation. So in the Capella model, I have defined certain requirements and given certain values based on the type of the requirement that I have defined. And I have also defined a type of relation, which is specifically a satisfied relation, that I connect requirement to the physical component that is in a Capella model. So we will use predicates as a way to say to get the requirements that has a pending status. So why this is useful is, say, at different stages of your development process, you can identify what are the requirements that are still pending, or you can identify requirements that do not have any status as pending or reviewed and so on. Okay, so here in my Capella, I have included a plugin to edit the configuration file. So it's a plugin that we have created that could be added to the Capella tool, and you can use it to create your own queries or predicates and so on. So here, this is a configuration file that I've already defined called Predicates. So this is basically how the configuration file will look like. And so here, this is the eCore input. This is going to be same for all your Capella models. And then the data source. So this is where I define if I want to get the physical function, the logical function, or physical component, and so on. And then you can see that for the physical function, if I want to query the name, I can get the name for example, let's say if it's a component, for the physical component, I can get the physical component name or the kind of the physical component and so on. And then finally, with the worksheet template, I have defined at the row 4 and 5, like the 4th row and 5th column, I want the table to start and display the physical component name. So this is how I'll define the configuration file. And you can already see there are certain predicates that I've already defined. So I'll launch MapleMBSE, and then on the side, we will also explain how the predicate works in each case. So the icons that you can see with the .MSE extension, so these are the configuration file. All you have to do is double click on it, and it's going to launch an Excel worksheet for you. So once it launches an Excel worksheet, it will ask you to select the Capella model that we want to work with. And we will select the Capella file directly. So I want to work with the IFE model, and I'll select the Capella file and open it. And this will load all the information of the Capella model in MapleMBSE. So you can see on the top, we are connected to the in-flight entertainment system sample. And this is just an introduction worksheet of what each worksheet is and what information is being displayed in all the worksheet. So here, I'm listing all the logical function that is in the in-flight entertainment sample. So you can see a list of all the functions. We have about close to 65 functions. And similarly, another view which lists only the physical functions in the model. So there is no query or there is no predicates or filtering that is applied to this two worksheets. So we are just displaying a flat list of all the functions in the model. So, but in this specific worksheet, I'm defining a predicate in which I want to display physical function which has no allocation to the behavioral component. So here, these are the list of functions that are not allocated to any component in the Capella model. Similarly, here, behavioral component without any function. So in the Capella model, if you remember from the IFE sample, you will have noticed that you define the physical component, which has the behavior component, and then we allocate the physical functions to these behavioral components. But these are the list of behavioral components which has no function allocated to it. So you can kind of get an idea from this, like how Predicate can be used to set your own modeling rules to check for quality or to check for consistency of your model development process. And so this is the worksheet that displays the functions with the most functional exchange. So these are just logical function with more than 3 incoming or outgoing relation. So again, this is just a combination of 2 queries that we already saw, where we wanted to first show the logical function with more than 3 input port, then more than 3 output port, and then we combine that we want to display only logical function that has more than 3 input and output ports. So MapleMBSE will just display that list. And finally, these are the physical functions that do not have a realization relation to the logical function, and so on. Finally, this is a worksheet where I have listed just few requirements so that it gives us a compact view and we can work with this. So here, these are list of all the requirements that in my Capella model. And for these requirements, what we will do is we will include a new predicate, and we want to filter out based on the status. Like I want to display the requirements that are status as reviewed only, and then we will update it to pending, and we will see how for each change in the query and how MapleMBSE is getting updated. So to do this, I will have to create my own predicate. Like I said, again, this is a editor that I've installed in Capella. Again, there is a separate webinar that goes in detail of how you can install the editor and how to create a configuration file in detail. But for the focus of today's webinar, I'll only focus on how we can work with predicates and how to create new predicates and update an existing predicate and so on. So here, this is specifically the schema that's to display the requirements. So here you can see, like I am displaying the requirement with ID, name, text, and also the status. And specifically, we are seeing the same information here in the worksheet, so which corresponds to the ID, the name of the requirement, the text, and the status here. So what I'll do is I'm going to just define a new predicate to, let's say I want to first get the requirements which has status as only reviewed. So I'm going to define a predicate. Let's call status of requirement. The syntax is a colon and equal to, and this is where you will define for which part of the query that we want to apply the filter to. So you can notice from the worksheet that it's the column H or the status column to which we have to apply the filter to. So from the table itself, we can identify that the filter has to be applied to the enumeration value attribute. So which should be equal to, let's say, to reviewed or pending. So I'm just going to copy this information because we want to apply the filter to the attribute. So I'm going to say for the enumeration value attribute, and specifically to the reference values, I want to include a filter. So here, basically what I have done with the predicate here is I have given a user defined name. And since we want to apply the filter to the enumeration value attribute, I have acquired or I have queried the enumeration value attribute and then dot value. So again, like all these information are something that you can get from the editor too. For example, let's say specific enumeration value that I want to query are with the status as reviewed. So if I use control space, MapleMBSE will automatically show you certain queries that you can use that's relevant to the Capella model. So I want to define it for the requirement name. So the way the name is being defined for the requirement is the requirement if long name. So I will access that information, and the filter value is reviewed. Okay, so I have added my filter here. So again, since we want to apply it to the attributes level, I'm querying the enumeration value attribute, and the value is where I have to give it as either reviewed or pending. So I'm accessing that value, and the name of that value should be reviewed. So I have just created a query here for the predicate. The next step to use the predicate in the actual query is I can just add it at the filter level. So here I'm going to add this with a comma. So this means that you can also notice that I can add multiple filters to a classifier. So if you remember from our slides about the query path expression, so this is the classifier, and like the values or the identifier, the RIF text. So these are the attribute values. So here I have just applied the filter, and I'm going to save this to my model. And I'm going to restart MapleMBSE now. And select the latest file with the changes. And then we will select the sample file. And I have MapleMBSE with information open. So now you can see, once I have applied the predicate filter, we are only seeing the status to be reviewed. And to change it to pending, it's very easy. So now all I have to do is I'm going to update my reviewed status to pending. And now I'm going to save these changes, and again select the config file that I want to open and the model. So here you can see the status for the requirement that's being defined and which is only pending. This is for this specific view, it seems very simple because we had only 5 requirements. But imagine you have thousands of requirements at different levels, or hundreds of requirements at different levels of the Capella architecture, and you want to query the whole model to get certain status, like or even as a validation check, say every time a certain set of users contribute to the model, they define their own relations, they change the status of the requirement to either pending, reviewed, or say there would be also cases where the user forgets to set change the status of this requirement to what is needed. In that case, you can, once you have defined the set of rules, like say I've already defined certain predicates for the other worksheets, and you can see like every time you launch MapleMBSE and connect to the model, you will automatically get the information based on the rules. And you can easily monitor now with at different stages of your project, like how many requirements are still pending, how many requests are how many requirements are being processed or in a state review, or how many requirements are there that do not have any status defined to it. And based on this, you can check like what would be done next? Like you could set up a review with the users to see how the changes has to be updated and so on. And again, once this information is made in MapleMBSE, you can easily update that information too. If you remember, I mentioned that the interaction with MapleMBSE and the Capella model is bidirectional. Like you can update an information in MapleMBSE and save it to the Capella model, or we can do the same from Capella to MapleMBSE and so on. So now let's say to define another predicate. So before I define the predicate, let me just change to the Capella workspace and show you how the requirements that I've already defined in the Capella is being connected to certain physical components. And our next goal is, say, I want to define a predicate which will filter out the requirements from the model that has no relation to any model element or to specifically in this case, I want to filter out requirements that has no link or satisfy relation to the physical component. So here you can see that these are the 5 requirements that we were able to initially see in Capella. And now there is only 2 requirements because we applied a filter and the status as pending. And here you will be able to notice that if I send this information to, you can see that there is only 2 requirements with the status pending and few other with the status review. Again, for 5 requirements, the view seems to be simple, but imagine that you have requirements in different levels and there are thousands of requirements in architecture. It's very simple to query the whole model and display it in a compact view. Okay, so now we can also see that we have certain requirements. For example, the requirement to watch movie, it has a relation. The second requirement also has a relation to a physical component, but the last 3, they do not have any relation. So say I want to create a predicate that will query the model and get me requirements that has no satisfy relation to any model element. So this is a satisfy relation that I've defined. Like for example, here you can see this is the review status and I have related the requirement using the specifically the requirement allocation and I have allocated it to a target element, which is the passenger remote control and so on. So this is how I have defined the model. And now we will define our specific query for getting the requirements that has no relation to a model element. So to define a predicate, I'm just going to create another predicate, and let's say related predicates. And so again, the way we are going to create the query is based on how the information is being displayed in the table. So previously we created a predicate because we wanted to apply a filter at the level of the status. So now we want to actually display the requirements which has no relation. So now the filter has to be applied to the requirement itself and not to the attribute. So that's why I'm going to access the requirements first. So I'm accessing the requirement, and the requirement is going to have certain attributes for relations. So again, this is defined based on the Capella echo. And this will be the incoming relation, because we saw from the model that the way I have actually related the requirement to the model is using the incoming relation, and the target will be a physical component in this case. So that's why I'm accessing the incoming relation, because that's how I have defined my relation in the model. So I have defined the predicate here, and the filter has to be applied to the requirement level. So I'm going to apply the filter here, and I'm going to remove the filter from the status now. So I'm going to save this information and restart my model and select the predicates. On the sample model. So in the requirements table, you can see that there is only two requirements, because what we have defined in this predicate is I want to see requirements that are only having a incoming relation, or it has a relation to a different model element. But our initial goal was to display requirements that has no kind of relation. So to do that, all I have to do is to include a logical operator not before before my query of the predicate. So I have just defined not. So what this will do is it will only display requirements that has no relation defined to it. So here I'm going to change and select the IFE sample. So now we will see requirements that has no relation. So now you can see that we have three different relations. And if you remember from the model, I initially showed to you in Capella, like the IFE sample, we saw there's two requirements which had a relation to physical component, but there were other three requirements that did not have any kind of relation. And that's why you are able to see the query is displaying you three requirements that has no relation to the model. So these are just custom queries that I created. I thought that might be of useful. Like I mentioned, the configuration file is completely customizable. You can see that you can define your own set of predicate rules to check your model consistency and quality. And also, once you have defined this, you can use the same configuration file with different projects or different models, and you can get the information based on these rules. So even in terms of reusability, once you define the queries, you can just launch MapleMBSE, connect to a Capella model, see the results, review it, and so on. So this is what I kind of wanted to show to you as a demo of how predicates work with MapleMBSE and how you can define your own predicates. And some of the common queries that we can use to check the model quality are, like, we can see if there are requirements in your whole model, and if there is any requirement that is not linked to any model element. And we can, for example, it could also bring in the information of all physical functions that are not allocated to a behavioral component and so on. Or similar to the queries that we created, if we want to check the status of a requirement, or if we want to bring in a requirement that has no status, we just have to include a not before the predicate in the ones that we just defined, and it will be able to bring the requirements of those specific cases. And imagine if you also define the ports, and there should be certain types, or if you're defining like ports that exchange certain information, and like say they are certain types of ports that are defined with, say, it should be real port, or information that exchange to the port should be real or integer, and so on. MapleMBSE can query specifically that port and check certain attributes of the ports and so on. Or if you have used the PVMT profile to define your own value properties, and you can use MapleMBSE to specifically query for properties and check if the type of value that is being defined for the property is real, integer, or if it's a string, and so on. The capability of defining your own query is very open, so you can customize it completely. So we are to the end of the webinar, and I'll give you a very quick summary of what we saw in today's webinar. Initially, we saw how MapleMBSE can provide an easy interface to view and edit the SysML model. We did not actually see the bidirectional workflow between how you update a model in MapleMBSE and Capella, and how the information is exchanged. Again, like I mentioned earlier, we do have other webinars that specifically focuses on this aspect. And so since the scope of this webinar was more focused on defining your own validation queries, I had to skip through it. Then we also saw what QP is. It's just a transformation language to query your model and bring that information to Excel worksheet. And specifically to these queries, you can add certain filters which will act as validation rules, and these are just predicates. So predicates are nothing but they are filters that will return you a Boolean value, like if it's true or false. And you can also combine different predicates. For example, say you want to display requirements that has status either as reviewed or status that is being reviewed or in process. And so you can combine different predicates together, or if you can even query the model based on certain values. You can query like how we saw for the logical function. You can query the model to see if it has certain attributes that is greater than a certain value or lesser than a certain value, and so on.